Work is equal to net force times displacement, where the force applied is parallel to the distance the object moves. The formula work equals force times displacement times cosine theta works as long as theta is the angle between the displacement and force vectors.
In this demonstration is pushing the wall but do have no work. This fighting exerting.
Exerting a lot of force because the wall doesn't move any distance.
In this demonstration, I also throwing no work because even though I lift the dumbbell up and down with no position and with displacement and no work. And also this demonstration, I will lifting a part of a flower.
According to physics, I am doing no work because I'm applying the force in the vertical direction while I'm walking in the horizontal direction, so the direction of force and displacement are perpendicular, and therefore no work is done. In this demonstration, the binder acts as a ramp. When I roll a marble down the ramp, it has the most gravitational potential energy at the top because it has the greatest height when it's at that position. However, at the bottom, it has the most kinetic energy because its velocity is the greatest. In the middle of the ramp, it has a mixture of both potential and kinetic energy. Similarly, this tennis ball has the greatest potential energy at the top of the hammock and zero kinetic energy there since it's not moving. At the bottom, it has maximum kinetic energy, but still some potential energy because it's still above the ground. Springs display a type of potential energy called elastic potential energy. Springs can be found in everyday objects such as staplers. The formula for elastic potential energy in a spring is potential energy equals 1/2 kx squared, where k is the spring constant, which varies from spring to spring depending on how stiff it is, and x is the distance that the spring has been stretched or compressed. The more stretched or compressed a spring is, the more energy it has. Springs can also be found in pens. Hooke's law states that the force in a spring is equal to negative k times x, where k is the spring constant and x is the distance that the spring has been stretched or compressed. However, this only works when a spring is being pulled down on, not when a weight is hung on it. The final concept is power, or the rate at which work is done. The formula for power is P equals W over T, which is power equals work over time. Since work can also be written as force times displacement, however, power can also be written as force times displacement over time, or force times velocity. So to calculate my power while I moved this textbook or this pair of scissors, I would have to divide the work I did by the time it took for me to do it. Or I could just measure my force and multiply that by the velocity of the object. Thanks for watching!